Okay, let's look at some sample problems that can help you prepare for your Module 4 test. So this first problem says I want to simplify radical negative 120. Now anytime you have a negative square root, we know that gives you an I. So I can rewrite this as I times the square root of 120. Now I'd like to break down 120 to see if I can simplify the radical. So 120 is 4 times 30, which is 2 times 2. So those are both prime. 3, which is prime and 10, and 5 and 2. So the only pairs I have here is I have a pair of 2's. So for my radical, I will take that 2, the pair of 2's on the inside becomes 1 on the outside. So those 2 in the box become the 2 on the outside. And then I'm left with a 3, a 5, and a 2, which multiplied together give me 30. So radical negative 120 is 2i radical 30. Okay, these second problems talk about performing some operations on complex numbers. We have a subtraction and we have a multiplication. So if you notice, this first one is subtraction because it has the subtraction sign. So subtraction, so this becomes 3 plus 2i, and then it will become plus negative 4 plus 6i. So the signs change in that second complex number. Then we could just add the numbers. So 3 plus negative 4 is negative 1, and 2i plus 6i is 8i. Okay, the next one is multiplication. So when you multiply things, and you notice it's multiplication because there's no addition or subtraction in between the parentheses, we'll FOIL. So 8 times 2 is 16. 8 times 3i is 24i. 2 times negative 4 is negative 8i. And negative 4i times 3i is negative 12i squared. So this is 16. These two can go together. So 16i minus 8i, or 24i minus 8i is 16i. And then we'll have negative 12i squared. But remember, I squared is negative 1. So this is really negative 12 times negative 1. So this becomes positive 12. And then I can add the 16 and the 12 together, and I will get 28 plus 16i. So very important to remember, when you have an I squared, it always becomes negative 1. Okay. So the next series of problems really is a bunch of solving quadratics by factoring, by completing the square, or by quadratic formula. Most people, I think, would default to doing the quadratic formula, but really any method is actually okay. I will do one by factoring, I will do one by completing the square, and then I'll do the rest by quadratic formula. So this first one, I'm going to get everything on one side. That's always a good place to start. So I have it in my standard quadratic form. So if I wanted to do the quadratic formula, I have a of 1, b of negative 7, and c of 10. But this actually factors. So if I factor it, 1 times 10 is 10. So I'm looking for two numbers that multiply to 10 and add to negative 7. Not very hard. Those are negative 5 and negative 2. Those multiply to positive 10. Those add to negative 7. So if I put my box, I've got my x squared, I've got my 10, I've got my negative 5x, and I've got my negative 2x. So I can take an x out here. In the second row, remember, the first term is negative, so I'll pull a negative out, and I can pull a negative 2 out. For this top, I can take an x out. And then the second two are 5 and 10, which is 5, but it's negative because the first one's negative. So our two factors are x minus 2, x minus 5. And as you can see, the numbers we ended up with our factors are exactly the same ones that were up here. Notice that this is the same as this. That is always true if the first number is 1. If that's an x squared, that always is true, so you can kind of save yourself some time on that rectangle box factoring. So x minus 2 equals 0, x minus 5 equals 0. So I'll solve that. I'll add 2 to both sides, so x equals 2. I'll add 5 here, so x equals 5. So if you can factor, it's a really fast, kind of nice way to solve these. But again, not all of them do factor. Okay, let's look at number 5. I'm going to do this one by completing the square. Everything is on one side, but to complete the square, we always move the c term. We move this to the other side. So this will give me x squared minus 4x equals negative 11. So now I'll do my complete the square term, which is half of this squared. So if I take negative 4 and I cut it in half and square it, that's negative 2 squared, which is 4. So I'll add 4 to both sides. So this will give me x minus 2, x minus 2 if I factor it, because these are two numbers that multiply to 4, add to negative 4. Remember, it has to be perfect, so it's always this number twice. Equals negative 7. So this is x minus 2 squared equal to negative 7. So I'll take the square root of both sides, so I'll get x minus 2 equals plus or minus the square root of negative 7, which I know is I square root of 7. 7 doesn't break down. It doesn't factor in anything, so it just stays like that. I'll add 2 to both sides. So my final answer is 2 plus or minus I times the square root of 7. So we have two complex solutions in this case. Quadratic formula would have got you the same thing, just plugging in numbers instead of doing this method. Let's look at number 6. I'm going to do the last 3 problems with quadratic formula, just because that will probably be what most students will choose to do. So remember, the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. So in our case, it's already in standard form. So a is 3, b is negative 7, and c is 1. So if I plug in those numbers, negative 7 is 7, plus or minus the square root of negative 7 squared, minus 4 times 3 times 1, all over 2 times 3. So it's 7 plus or minus, so this discriminant, negative 7 squared is 49, negative 7 times 3 times 1 is negative 12. So if I subtract those, 49 minus 12 is 37 over 6. So the only question is, does this 37 break down? Now if you try to break down 37, is there anything that breaks into 37? No, it's prime. So these are just our two solutions. 7 plus root 37 over 6, 7 minus root 37 over 6. So on the test, it certainly could break down. We got kind of lucky here. Okay, let's look to number 7. Now this one, x times x minus 3 equals 3, is not in standard form. We've got something on the other side, and we don't even have a square right now. So we have to kind of make it look like standard form first. So I would distribute this x. So this gives me x squared minus 3x equals 3. And then I would subtract 3 from both sides. So x squared minus 3x minus 3 equals 0. So now I can use my quadratic formula. X equals negative b, so that's 3, negative 3, plus or minus the square root of negative 3 squared minus 4 times a, which is 1, times c, which is negative 3. I'm not even going to put the 1 because I know it doesn't do anything. You're welcome to. Over 2 times 1, which is 2. So this will be x equal to 3 plus or minus the square root. Now our discriminant here, negative 3 squared is 9, and negative 4 times negative 3 is positive 12. So 9 plus 12 is 21. over 2. Well, ironically, we have another problem that doesn't break down because 21 is 7 and 3, but there's no groups of 2. So it just stays as this. Okay, let's look at the last one on this page. Number 8 says x squared equals 125. So this one is tempting to try to do other things with, but remember, we should always get things on one side before we do the quadratic formula. So in this case, a is 1, but there's no x term, so remember we say b is 0. c is negative 125. So if I use the quadratic formula, it's negative b, which would be 0, negative 0, 0 doesn't matter, plus or minus the square root, b squared, which is 0, I'm not even going to put it, minus 4 times a times c all over 2a. So the 0 in front we don't really have to really write, so this is really plus or minus the square root of 500 all over 2. Well, let's see if this simplifies, because I'm pretty confident 500 will simplify. So if I break this down, it's definitely 5 and 100. So there's my prime. It's 10 and 10. And this can be broken down as 5 and 2 and 5 and 2. But now if you look at this, we have a pair of 5s and a pair of 2s with just a lone 5 left over. So the way I would write it, we have plus or minus, so I take a 5 and a 2 out, and a 5 and a 2 go out there, and then a 5 left inside, all over 2. Now 5 and 2 is going to be 10, but you'll notice this can actually cancel with this 2. So we're done. Our solution is plus or minus 5 times the square root of 5. Negative sign. Okay, so let's move on to the second part of our module, which was admittedly the trickier or easier part of the thing, which where we are graphing these parabolas and these quadratics. So number 9 says, in the graph below, identify the x-intercepts, y-intercepts, the vertex, and the axis of symmetry. Okay, so the x-intercepts, remember where the graph crosses the x-axis, so that would be here and here. So those are my x-intercepts. Now if you graph a function on Desmos, remember you can just click on those dots and it'll tell you what the ordered points are. In this case it's somewhere, not exactly, but it's close to negative 1, 0, and 5, 0. The y-intercept is where the graph crosses the y-axis, and so that's here. So the y-intercept in this case looks to be 0, negative 4. The vertex is at the top or the bottom of the parabola. So in this case it's at the bottom because this one opens upwards, so this would be here. So that looks to be at the point 2, negative 8. So the last one we have to find is the axis of symmetry. Now remember the axis of symmetry is the vertical line that goes through the vertex. So it's this line that goes right through here that cuts the parabola in half. This is really easy to find. It's just x equal to whatever the x part of the vertex is. See the first part of our vertex is 2? So our axis of symmetry is x equal 2. Remember, I can't stress this enough, any graphing problem, please graph it. Look at your graph. Use that graph to get your information. Okay, number 10. What is the vertex and axis of symmetry for the quadratic? Now, if I could graph it, we could check it, but we'll do it the algebraic way. And then you could certainly check it with your graph on Desmos. So the vertex, remember, we always start with doing x equal negative b over 2a. This gives us the x coordinate of our vertex. So in this case, that would be negative 4, so positive 4 over 2 times 2. That is going to be 1, because that's 4 over 4. So my vertex is going to be 1 comma something. What I don't know is the y-coordinate. But since this is my quadratic, I can plug in this for y, or for x. So this will tell me the y part. So y equals 2 times 1 squared minus 4 times 1 minus 3. So this is 2 minus 7, so this is negative 5. So this is my vertex. So if I were to graph this on Desmos, you can do that. Basically to have a point here, and I know it would open something like this. Okay, let's look for the x and y intercepts of this quadratic. X squared plus 2x minus 9. Now again, you could graph it and see what they are, but algebraically we can find that as well. So for the y-intercept, this is the easier of the two, we just set x equal to 0. So in my function up here, x squared plus 2x minus 9, I'll just put 0 in for all the y's. So y equals 0 squared plus 2 times 0 minus 9 equals negative 9. So my y-intercept would be 0, negative 9. Now my x-intercept is a little trickier because I want to set y equal to 0. So I will put 0 equal x squared plus 2x minus 9. Now this is important because a lot of times even the Desmos calculator will give you a decimal approximation when you actually might want the actual values. So once we have this though, this is a quadratic equation. You could use quadratic formula, we could use complete the square, whatever you want. I'll use quadratic formula. So negative 2 plus or minus 2 squared minus 4 times a, which is 1, times c, which is negative 9, over 2 times 1. So our discriminant here is 2 squared, which is going to be 4. The negative 4 times negative 9 is positive 36. This is a 9. So when we simplify this, this will be x equal negative 2 plus or minus 4 plus 36 is 40 over 2. So I can simplify 40. It's 4 and 10. It's 2 and 2. It's 2 and 5. So I've got one group of 2's and a 2 and a 5 left. So this group of 2's here will come out, and this 5 and 2 will stay in as 10, because 5 times 2 is 10. So now I'll look at these numbers and see, can I divide them all by something? Well, they're all the same, so sure, we can divide them all by 1. So our x-intercepts are going to be 1 plus or minus 1 square root of 10. So those are some weird irrational numbers, but those are actual points on our x-axis. So those would be where the graph crosses the x-axis. Okay, our last problem talks about complete the square to go to vertex form. Now if you remember vertex form is y equals x minus h squared plus k, where h and k is our vertex. So it's kind of a different form to write the quadratic, and it gives you the vertex a little easier than we did above. So the way we do this is we will complete the square. So I'll take this c term, negative 9, I'll move it down a little bit. So now I'll complete the square on this term. So I take half of 2, which is 1, and I square it, which is 1 as well. So again, I take 2, I divide it by 2, and I square it, which is 1 squared, which is 1. So I add that, so these first 3 are now going to make a perfect square trinomial. But to balance it out, I'm going to subtract 1 again. So these two will go together because they're both numbers. So now I can factor x squared plus 2x plus 1, because two numbers that multiply to 1 to add to 2 are 1 and 1. So this factors as x plus 1, or x plus 1 squared. And then we have minus 1 times minus 9 is minus 10. So just by that simple little conversion, we have it in vertex form. And now the nice thing about vertex form, I know the vertex right away. It's the opposite of what's in the parentheses, so negative 1 and it's the number outside the parentheses, it's negative 10. Again, I can't stress enough, with these graphing problems, make sure you're graphing them on Desmos, checking the points, making sure everything is correct. All right, good luck on your test. I hope this review was helpful.